Welcome everyone to this Cyventra Technologies Training Explainer. Today, we're diving into something absolutely crucial for cloud engineers, cybersecurity students, and IT pros alike, and that is AWS security. Now, Amazon Web Services powers millions of applications all over the globe, but there's this really dangerous myth floating around out there. A lot of organizations kind of just assume that the second they move their operations into the cloud, they're automatically secure. Well, reality check, they aren't. Even tiny configuration mistakes can completely expose sensitive information, open up massive vulnerabilities, and lead to some incredibly costly data breaches. So in this explainer, we're going to break down the 10 most common AWS security mistakes. We'll look at why teams make them, the real-world business scenarios that lead to these breaches, and most importantly, exactly how to fix them using proven best practices.
Okay, let's jump right into our curriculum for today. We're going to start with the shared responsibility model, then move into identity and access security, tackle data and network protection, explore monitoring and disaster recovery, and wrap the whole thing up with continuous security best practices.
All right, Section 1, the shared responsibility model.
To really get cloud security, we first have to totally shatter the illusion that the cloud is secure by default. It all comes down to the AWS shared responsibility model. Think of it like this. AWS handles securing the cloud itself. That means they're on the hook for the physical data centers, the core networking infrastructure, the hardware, and the virtualization layer. But you are responsible for securing in the cloud. You have to manage user access, configure your services properly, encrypt sensitive data, and monitor what's going on. The reason cloud security gets so misunderstood is that teams just assume AWS is wrapping this magic blanket of security over everything they deploy. But the reality is, AWS secures the building, so to speak, but you are entirely responsible for locking your own doors and securing your own data. Misunderstanding this simple division is exactly where most breaches start.
Moving right along to Section 2, identity and access security. Let's look at our first layer of defense, starting with two major blunders. Mistake number 1 is using the AWS root account for everyday tasks. Look, the root account has unrestricted access to literally everything. Why do teams do this? Honestly, it's usually just laziness or rushing during the initial setup. A pretty classic scenario is a systems admin logging in as root just to quickly fix a billing glitch, but then they leave the session open, or worse, they save the password in their browser. If an attacker gets those credentials, it is game over. They own your entire environment. The fix here? Lock those root credentials away, physically in a vault. Use them strictly for emergencies and rely on IAM Identity Center for your daily routines. Mistake number 2 is granting excessive IAM permissions. This usually happens when teams are scrambling to hit deadlines. Imagine a developer is complaining that a test script keeps failing, so a well-meaning IT manager just gives them full administrator access to bypass the roadblock. This completely violates the principle of least privilege and blows your attack surface wide open. You absolutely have to implement strict role-based access so users and apps only get the exact permissions they actually need, nothing more. Continuing with identity, mistake number 3 is skipping multi-factor authentication, or MFA. Passwords on their own, they are practically useless against modern attacks. So why is MFA so often ignored? User friction. People just complain about the extra step. But picture this, a super convincing phishing email perfectly mimics your company login page and grabs a high-level manager's password. Without MFA, that attacker just walks right through the front door. The solution is non-negotiable. Security teams need to enforce MFA policies universally using AWS organizations. Then we have mistake number 4, leaving hard-coded AWS credentials in applications or Git repositories. This happens all the time when developers are trying to do fast local testing. Say an intern hard codes access keys right into an app source code, forgets to take them out, and pushes that code to a public GitHub repo. There are automated botnets scanning public repos 24/7. Those keys will be scraped and used to spin up massive crypto mining operations in a matter of seconds. You have to use AWS Secrets Manager and temporary IAM roles instead of ever relying on static hard-coded secrets.
Next up, Section 3, data and network protection.
Now that we've secured who gets into your environment, we have to protect what actually lives inside it. It's a pretty terrifying question, but mistake number 5, publicly accessible Amazon S3 buckets, is hands down one of the most notorious AWS security blunders out there. We've seen thousands of organizations accidentally leak financial reports, customer records, and confidential source code, literally all because they misconfigured their storage bucket permissions.
So why do S3 misconfigurations happen so incredibly often? Well, it almost always boils down to confusion between S3 access control lists, or ACLs, and complex IAM policies.
Think about a marketing team that needs to make a bucket public to host a promo video on their website. They flip the switch to public, totally unaware that an automated script has been backing up the entire customer database into a different folder inside that exact same bucket. Ouch. The practical fix for administrators is to enable S3 block public access at the account level right from day one. From there, audit your policies, make sure you encrypt sensitive objects, and always enable versioning so you have a clear recovery path if things go sideways.
Let's tackle 2 more massive oversights. Mistake number 6 is failing to encrypt data at rest and in transit. A lot of organizations skip encryption because they're worried about performance hits, or they just think it's too complex to manage. But imagine an attacker manages to steal an underlying EBS snapshot of your database volume. If it isn't encrypted, they can just mount it and read everything. By using the AWS Key Management Service, or KMS, across S3, EBS, and RDS, you guarantee your data stays protected even if unauthorized access happens. Mistake number 7 is poor security group and network ACL configurations. Usually this is because of legacy apps or maybe network admins setting things up quickly to work from home. A classic, devastating scenario is leaving port 22 for SSH or port 3389 for RDP open to 0.0.0.0/0. That means it is open to the entire internet. You are basically rolling out the red carpet for brute force and ransomware attacks. You have to practice strict network segmentation, restrict inbound traffic, use private subnets, and honestly, just use AWS Systems Manager Session Manager instead of opening direct ports in the first place.
All right, moving into Section 4, Monitoring and Disaster Recovery. We've built some strong walls, but how do you proactively detect threats when they inevitably test those walls? That brings us to mistake number 8, not enabling CloudTrail, CloudWatch, AWS Config, GuardDuty, and Security Hub. You literally can't protect what you cannot see. Organizations often skip these because they're scared of the storage costs for massive log files, or they just don't have the staff to query them. But imagine an attacker gains a foothold and just quietly sits in your network for 6 months, slowly siphoning out sensitive intellectual property. If CloudTrail is turned off, you have 0 alarms and 0 evidence. Enabling these core continuous monitoring services is absolutely non-negotiable. They act as your automated eyes and ears to detect unusual logins, weird API calls, and policy violations as they happen in real time. This 30-day timeline perfectly illustrates our final 2 common mistakes: ignoring security updates and missing disaster recovery strategies. Mistake number 9 is failing to patch systems, usually delayed because teams are terrified of breaking production environments. Mistake number 10 is lacking backups, or setting them up once and never actually testing them. Let's look at a real-world scenario. Day 1, a known vulnerability is left unpatched. Day 15, an attacker exploits that 0-day vulnerability to breach the system. By day 30, ransomware is deployed, encrypting everything. The company panics and tries to restore from backups, but the recovery totally fails because the backups were stored in the exact same region and were encrypted by the attacker too. To avoid this, administrators need to use tools like AWS Systems Manager Patch Manager for automated updates, and crucially, maintain automated cross-region backups that are tested regularly. Finally, Section 5, Continuous Security Best Practices. Let's wrap up the Cyventra Technologies Explainer by consolidating all of these solutions into a highly actionable checklist. If you want to dramatically reduce your risk, strictly enforce these 10 practices. 1. Never use your root account for the daily grind. 2. Universally enforce multi-factor authentication. 3. Always apply the principle of least privilege across your IAM policies. 4. Aggressively block public access to your S3 buckets. 5. Mandate encryption for all sensitive data. 6. Lock down your security groups and kill those open internet ports. 7. Turn on continuous logging and threat detection. 8. Completely eradicate hard-coded keys using Secrets Manager. 9. Keep your infrastructure relentlessly updated. And 10. Maintain cross-region disaster recovery backups that you actually test. So, bringing it all back to where we started, the shared responsibility model. AWS really does provide an incredibly robust and secure physical platform, but the vast majority of cloud breaches don't happen because Amazon's infrastructure failed. They happen because of preventable misconfigurations and operational oversight on the customer's end. When you understand the root causes of these common mistakes, you can actively build a resilient, compliant cloud environment. I want to leave you with this one imperative mindset. Security is a continuous process. It is not a one-time set it and forget it checkbox. As your business needs shift, as your applications scale up, and as entirely new attack vectors emerge, your defenses have to evolve right alongside them. So ask yourself, is your AWS environment truly ready for tomorrow's threats? Stay vigilant, keep auditing those configurations, and continue advancing your cloud security expertise with Cyventra technologies. Thanks so much for joining me in this explainer, and stay secure out there.